The Spero microscope is changing the face of infrared microscopy for us. We can reconstruct information in 3 dimensions, in quantitative way, and we can have access to metabolic, to biochemical, to structural, to anatomical parameters that we could not do before. Infrared spectroscopy and microscopy is providing a global chemical picture of your sample. You can access to different chemical parameters, with the big advantage is that you don't need to label or to stain your sample before. Now, because the new microscope become much faster, so giving access to larger samples, we can even envision the 3D reconstruction of the chemical information from the sample, and we can turn that into biological information.
What we're trying to do is take the research out of the instrumentation and make the instrumentation robust and easy to use, so that the thing you spend most of your time on as a researcher is analyzing the results and making sense of it, because that's really going to be the impact, in this industry.
The Spero microscope has 2 or 3 big advantages. The first one is that it's using a laser source, which is much more powerful than the previous sources, the global sources. And so it's giving access to a very high signal-to-noise ratio, which can be maintained over a very long time of acquisitions. You have to couple this first advantage with the second one, which is that we use now detectors which are not liquid nitrogen cooled. So making that the detector can be used for very long time of acquisitions. In this case, when you combine these 2 advantages, you can use it for very long acquisitions, and because it's 50 times faster than before, then you can have access to a large data set in very short time. If you consider a mouse brain, which is about 400 to 500 sections, 2D sections, it was lasting something like a year before, so this is why we are not doing it. And now you can get this information in a few weeks only.
This motivates us to want to take the technology even further. They're saying, hey, you've taken it down from a year to a few weeks, that's fantastic. But we're also hearing, hey, we'd like to get that down to a single day. And we think the technology can be scaled to that level. So we're not going to stop, and we're going to continue to support these researchers on the cutting edge.
This first experience with the Spero microscope is making that 3D is something real now. It was feasible just as a proof of principle before. But now, really we can analyze what is the chemical behavior of the tumor related to its environment. So that is really changing the face of our cancer research on that.